Dear students, in this video I am going to discuss about cryptography as a security tool in operating system. Generally, in an isolated computer, the operating system will be having a full control on the entire channels in the computer system. So therefore, the operating system can reliably determine who is the sender and recipient of the messages in the inter-process communication. But whereas in the network of computers, this situation is quite different because in networked computers, they receive bits from wire with no prior or immediate way of knowing or determining what machine or application has sent those bits. Similarly, the computer sends the bits onto the network with not knowing who might eventually receive them. So this is the problem with the network computers in order to determine who is the sender and receiver of the messages. Generally, network addresses are used to infer the potential sender and receiver of the messages because the network packets arrive with the source address that define the IP address of the system. And when computer sends a message, it names the intended receiver by specifying its destination address. So therefore, every time when a computer sends the message will be having the source or the destination address of that particular message. So generally for applications where the security is the matter, so it is the responsibility of the operating system to assume and guarantee that the source or destination at the address of the packet reliably determines who sent the message or who is receiving that message. An intruder's computer and a computer with some attacker can send a message with a falsified source address. Therefore, the message will reach to the computers who is not intended for that particular message or numerous other computers on the way to reach the destination because all the routers on the way to the destination will receive the packet. So therefore, it is an operating system to decide whether to grant a request when it cannot trust the named source of the request. So that means if the operating system is not able to trust the source of the request, then it can decide whether to send the reply to that message or not. And the operating system is supposed to provide protection for the request or data when it is not able to determine who will receive the response or message contents it sends over the network. So these are the two responsibilities of the operating system to decide on whether to send the reply messages or receive the request messages in the network. In order to solve this problem, the cryptography is one of the ancient technology used in the computers in order to provide the secure way of transferring the messages between two systems or systems connected in the network. So cryptography enables a recipient of a message to verify that the message was created by some computer possessing a certain key. The key is the source of the message. Similarly, the sender can encode its message so that only the computer with a certain key can decode that message, so that the key becomes the destination. Unlike network addresses, the keys are designed in such a way that it is computationally not feasible to derive them from the messages or not feasible to generate them from any other public information. Thus, they provide more trustworthy means of sending and receiving the messages in the network. So, cryptography means it constrains both senders and receivers of the messages. The cryptography technique is based on the keys. It enables the confirmation of the source. It enables the receipt of the message only by the certain destination. It establishes the trust relation between the sender and receiver. Encryption is a means for constraining the possible receivers of a message. An encryption algorithm enables the sender or receiver of the message to ensure that only computer possessing certain key can only read the message. The encryption of messages is an ancient practice, and there have many encryption algorithms. One of the encryption algorithm here, K is set of keys, M is set of messages, C is set of ciphertext. The encryption function E convert the message M into a ciphertext C by applying the key K. A decryption function D decrypt the ciphertext into the original message by applying the decryption key. So therefore, the encryption key EK and decryption key DK should be efficiently computable functions. An encryption algorithm must provide this essential property because given the ciphertext C, a computer can compute the message M from the ciphertext C such that if it possesses the key K. Thus, a computer holding K can decrypt the ciphertext to the plain text, but a computer not holding K cannot decrypt the ciphertext. Since ciphertexts are generally exposed, it is very important that it is infeasible to derive K from the ciphertext. It is very important that there should not be any possibility to derive K from the ciphertext. Symmetric encryption uses same key for encryption as well as decryption. DES is a data encryption standard. It is one algorithm that is most commonly used symmetric block encryption algorithm. This algorithm encrypts a block of data at a time, and the block size of this encryption algorithm is 64-bit. This 64-bit encryption algorithm nowadays is assumed to be too short and insecure nowadays. So therefore, another variation of the DES algorithm, that is triple DES algorithm, is used. It is considered as a more secure algorithm because it uses 3 times the DES algorithm using 2 or 3 keys. For example, first the message is encrypted by using first key K1, and whatever ciphertext is obtained, it is decrypted with K2, and whatever output is obtained from this application of K2, that message will be again encrypted with the help of the third key. So that means the output of the first key is input to the encryption function with key K2, then the output of the encryption function with K2 will be an input for the encryption function K3. So likewise 3 times this DES algorithm is applied. Finally, whatever output is generated, that is treated as the ciphertext and is transmitted over the network. Advanced encryption standard AES is the another encryption algorithm. It uses 128 bits or 192 bits or 256 bits of. It encrypts a block of size either 128 bits or 192 bits or 256 bits. So RC4 is another most popularly used encryption algorithm. It uses the encryption or decryption for a stream of bytes. That means it will apply this algorithm for a stream of bytes. Byte by byte it will encrypt or decrypt. So like that it generates an infinite key streams. Let us take up an example how this symmetric encryption performs. Initially, the message M is written. This message M is considered as a plain text. it is applied to the encryption algorithm E, the user encrypt the given plain text by using the encryption key K and generates a ciphertext C. C is the ciphertext generated by applying the encrypted key. So, in the network, if an attacker is trying to find the message in the network, the attacker could see only the encrypted form of the message, that is ciphertext C. So, therefore, the attacker could not interpret what the message is originally. Then the ciphertext will be decrypted at the receiver side by supplying a decryption key K. A plain text is generated once the decryption is done with the decryption key, and finally that message will be read by the receiver. So this is the secure way of communicating over the insecure medium with the help of the symmetric encryption. Here the key used for both encryption and decryption is same. That is why it is called as symmetric encryption. Asymmetric encryption. Here the key used for encryption and key used for decryption are different. The key which is used for performing the encryption is called as public key. Key which is used for decrypting the ciphertext is called as private key. This encryption key is made public because it is not possible to find the private key from the public key. One of the example for the asymmetric encryption. KE is a public key, KD is a private key. N is a product of two large prime numbers P and Q. The message M is encrypted with the help of this encryption key KE and the number N. The decryption key KD is identified with the formula that satisfies KE KD mod P minus 1 into Q minus 1 is equal to 1. That is, the decryption key multiplied with the encryption key, this product mod, the product of P minus 1 and Q minus 1 is equal to 1. This condition satisfies for the encryption key and decryption key. So finally the algorithm for decrypting the message is applying the decryption message on the ciphertext and performing the mod operation with N that generates the decrypted message. Let us take up one example for the asymmetric encryption. Let us consider two prime numbers P and Q. So P is equal to 7, Q is equal to 13. We calculate the value of N as the product of P and Q. So product of 7 and 13 is 91. And the product of P minus 1 and Q minus 1 is 72. Now the encryption key KE is to be chosen which is relatively prime to 72. Here a relatively prime to 72 and it should be less than 72. So for example consider 5. The factors of 5 is 1 and 5. The factors of 72 are 1, 2, 3, 4, 6, 8, 10 like this up to 72. These are the factors of 72. So 5 is a relative prime to 72 because other than 1 there is no common factor here. So therefore 5 is the encryption key chosen here. 5 is the encryption key KE. Now we need to identify the decryption key KD from this. The equation to be satisfied is KE KD, the multiplication of KE and KD mod P minus 1 Q minus 1 should be equal to 1. This is the condition to be satisfied when we choose the value of KD. So value of KD is here chosen as 29 because here KE is substituted as 5. And we know the value of P minus 1 and Q minus 1, that is 72. So this should be equal to 1. So what should be the value of KD here? Suppose if we substitute the value of KD as 29, then this equation will become equal to 1. So this condition is satisfied if we take the value of KD as 29. So 29 will become KD, decryption key. So now we want to encrypt the message 69 by using this asymmetric encryption. Let us take up this example. The message is 69. It is a plain text. So we need to convert this into a ciphertext. The conversion process is given the message m power, apply the encryption key KE, mod, apply the mod function with 91. So this 69 is the original message which is raised to the power of encryption key, that is 5 mod 91. So this will generate the output, that is 62. This output is called as ciphertext. This ciphertext is the encrypted version of the plain text. This ciphertext will be transmitted to the destination over this insecure channel. Once this message is received at the destination, then the receiver will apply the decryption key. So the decryption key KD is 29 here, which is already seen in the previous slide. So we apply 29. So 62 is raised with the power of 29 and mod 91 is applied. So 91 is the product of P and Q. So where P is 7 and Q is 13. So 62 power 29 mod 91. So this will generate the original text back, that is 69. So this is interpreted from the ciphertext by applying the decryption key. In this way, the encryption is done with the help of the public key and decryption is done with the help of private key. So this is an example of RSA algorithm. Here one important point to be noted is symmetric cryptography is based on transformations, whereas asymmetric cryptography is based on mathematical functions. So therefore asymmetric cryptography is more computation intensive and hence it is not used for bulk data encryption. Thank you for watching this video.